Here's the situation. This new image from Thailand shouldn't appear like this. When a comet is passed through a Larson's second rotational gradient, one would anticipate symmetry, some noise, perhaps a faint tail. What you're observing here is neither subtle nor symmetric. A bright, structured feature is directed straight at the sun, not drifting, not fading, nor breaking apart. It maintains its shape consistently, frame after frame. Take a closer look at the center. The inner coma isn't exhibiting a smooth glow. It's elongated. Something within 3I Atlas is propelling material sunward in a manner that comets just don't do. Despite 2 weeks of observation, the orientation hasn't shifted, and the structure remains intact. If this were merely processing artifacts, the direction would become scrambled. If it was dust, it wouldn't maintain this coherence. And if it were solar pressure, it would be directed away from the sun rather than toward it. Therefore, right from the initial image of the night, the message becomes abundantly clear. Whatever 3I Atlas is doing, it is doing so again. And it is increasingly difficult to explain using standard comet physics. Now, let's juxtapose the images from December 7th and December 9th. When you view them side by side, the pattern becomes impossible to miss. In the left frame from December 7th, a small, tight feature directed toward the sun is visible. It's there, albeit faint, almost reluctant. The jet barely extends beyond the nucleus, and the secondary structure on the opposite side is just a whisper. If you weren't aware of what you were viewing, you might mistake it for noise. But the right-hand image, taken just 48 hours later, eliminates that uncertainty. The same structure persists, pointing in the exact same direction. But now it is elongated, brighter, and clearly divided into two components. The main sunward plume has become longer and sharper. The counter feature is more pronounced, and the overall structure has widened into a more V-shaped formation. Here's what stands out when comparing the two. The direction remained unchanged. This isn't a random artifact. The axes align perfectly across both nights. The brightness has increased, indicating a genuine physical source intensifying, not image noise. The structure itself has expanded. The plume is nearly twice the length in the December 9th frame. The symmetry has improved as well, with both sides of the feature now visible. Not just the primary plume. And here is where it becomes difficult to align with standard comet models. Features like this aren't expected to maintain such stability. Dust fans typically rotate, gas jets wobble, and viewing angles shift. Yet this entity holds its line as if it were a fixed engine. 2 nights, 2 images, same direction, stronger signal. Whatever 3I Atlas is doing, it is doing it with remarkable consistency. Now let's focus on today's raw frames. The standard grayscale, the inverted version, and the color-enhanced map. Together, these three convey a narrative that the naked eye might overlook. Starting with the left panel, the nucleus is a tightly focused point. There's no distortion, breakup, or secondary peaks. If you only examined this version, you'd conclude that 3I Atlas is an entirely ordinary comet just meandering through space. No drama here. Next, in the middle frame, the inverted grayscale, that's where subtle structures typically emerge. But once again, the core remains astonishingly compact. There are no signs of fragmentation, no fanning out, nothing explaining those unusual sunward features we just noted in the rotational gradient images. Now, shifting to the right panel, the color-enhanced map, everything changes. The outer halo lights up the brightness distribution extends more toward the sunward direction than the antisolar direction, which is not typical behavior for comets. Normally, you would expect the strongest intensity to be opposite the sun, where dust is pushed away. Here, it's the opposite. The area facing the sun is the one presenting the excess signal. That discrepancy, a tight core, a calm interior, but an outer layer, brightening in a specific direction, raises serious concerns. If 3I Atlas were disintegrating, the nucleus would appear chaotic. If it were venting normally, the antisolar tail would dominate the scene. If the structure was simply noise, it wouldn't align across all 3 processing modes. Yet none of those scenarios are unfolding here. Instead, the core remains stable, almost stubbornly so. The halo displays directional traits yet goes against expectations, and the color map confirms that real energy is being channeled into that sunward area. Something is quietly, persistently injecting momentum into that side of the coma without disrupting the nucleus. That's not how comets behave. It's not how interstellar visitors act either. And yet, 3I Atlas continues to exhibit these traits. Now, we transition to Italy, where Tony Scarato captured 2 new frames that perfectly align with those recorded in Thailand. They were taken using entirely different optics, filters, and processing techniques. This variation is what makes it so compelling. On the left, you have the raw natural light stacked exposure. Even without enhancement, the coma does not act like a simple fuzzy blob. There's a very faint forward brightening directed toward the sun, aligning with the direction noted in the Thailand data. There's no split, no asymmetrical breakout, no fragmentation halo, just a dense, stable core coupled with a forward push. On the right, after applying a Larson's second rotational gradient, the structure becomes clear. The central pixel is incredibly tight, measuring around 4,000 kilometers across on this scale. However, the crucial element here is the narrow, bright extension shooting sunward from the nucleus. It isn't bending or dispersing like dust. It is focused. The tail, as expected, points away from the sun, but this feature is directed right toward it, just as seen in the recordings from Thailand on both December 7th and December 9th. Different country, different telescope, different night, same structure. So, where do we find ourselves today? Numerous observers from various countries on different nights are all capturing the same forward-facing structure in 3i Atlas. A feature that shouldn't possess this kind of stability, shouldn't shine so brightly, and absolutely shouldn't point toward the sun with such consistency. Something is propelling this phenomenon, and whatever it is, it's not behaving like a standard interstellar comet. Now, I'm curious to hear your thoughts. Is this merely an unusually active nucleus? A jet we've observed from the perfect angle? Or does 3i Atlas suggest something entirely different? Share your opinions in the comments. I read every one of them, and if you wish to track this object as it evolves, night by night, please hit like, subscribe, and share this video with anyone who has been following the 3i Atlas saga. We're only just getting started.